I speak a little bit about the German perspectives and the collaboration between Germany and the United States. First of all, a short overview of showing a little bit the great and interesting times in we are at present, because it's a time of change on the one side, and it's a time where we really can use the International Space Station, and it's also some great challenges ahead of us, both on the private side and on the government side for exploration. So Germany was involved in first in space flight at all for many years, and later also in human space flight. And we are very thankful for the Americans to have invited us to join in the shuttle program. Because you probably know, or many of you probably know, Germany had plans to build its own shuttle. It was called Sänger. Later, ESA said, okay, we will build our European shuttle, which is the Hermes program. And then the United States came with the offer to join into the shuttle program. So Germany agreed to build the Space Lab facility. And the Space Lab facility was then given over to the United States and to America. And then this was kind of the way in which we bought into the shuttle program. So, and we are very thankful for this, and I think this collaboration was great, and we made many friends. And I also think this is a way also to go into the future. Now, the first shuttle flight in which we were involved was the Space Lab STS-9 mission. It was not the first it was the first shuttle flight also in which we were involved directly, and we flew also our first West German astronaut here. He is now for sure very, very famous in Germany. Not so much here, but for us he is very famous. And here you see a little picture of the Space Lab facility. I was involved myself as a scientist usually, and I said, well, I do. Mostly I will collect urines from the astronaut because it doesn't take crew time. But I was really very naive, because you see this tunnel here. The Space Lab is here, and whenever I wanted a urine sample from an astronaut, the astronaut had to come here and to go into the restroom and in the mid-deck and fly back and go back then to work, and this really costs crew time. So I learned a lot, but for sure I was able and allowed to do my experiments. Next one was the D1 mission. Germany thought we will have many upcoming D missions in the Space Lab and use the Space Lab extensively. But also in Germany there were then budget cuts, and then ESA came and we joined the program. And then the missions, everything Germany did basically went together with the ESA and the European Space Agency. And there was the D2 mission in 1993 with lots of experiments. And altogether, there were very many experiments which were done in the German life sciences program. I'm a life scientist. You see here, up to 2007, there were over 500 experiments in space, and a big chunk of those experiments was done on the shuttle. For sure, we also collaborated and still collaborate with the Russians, also directly. We had already our first experiments even in the Apollo phase. Actually, also my institute had, this was long before my times at the institute, but I'm educated by older people that we already had participated in Apollo flights. Now on the ISS, up to February 2011, you can see here all German experiments on the ISS now. We have about 40 already completed and ongoing experiments. And you see here the distribution of those experiments might be interesting for you. You see here life sciences, medicine, biotechnology is life sciences, radiation is basically life science, and gravitational biology is life sciences. So the biggest part of the experiments on this on the ISS is life sciences, has been life sciences. This has also to do with hardware, and it will change a little bit in the future, because the material scientists were always complaining we have lots of experiments waiting, but no hardware. But now in the future there will also be hardware, so it might shift. But there's a strong involvement of Germany in the life sciences experiments. Now, when we look to the philosophy, we have a little bit of different philosophy for our life science experiments, because at NASA, the biggest philosophy now is to look for the risks and mitigate risks. In Europe, we rather say, okay, we have no human spacecraft, so risk mitigation will always be done by NASA and by those countries who have have to operate the spacecraft. So we go more into science and into research. And also, we don't really have to, in Europe, to promise about spin-offs. We say, okay, we look to ISS rather as a lab, a huge lab, and we can answer scientific questions in this lab. And for us, it's also a little bit, it's just a lab. It's not a separation between space and Earth. It's a lab, and when we have questions in this lab, questions in microgravity, it tells us we do not know something in our basic knowledge, and therefore it's not a space question, it's just a science question. And we use the ISS as a scientific laboratory. Now, let me give you one experiment, one example of how we do experiments. You can just look at it like a chess play. Now let's play chess a little bit, because this is, I think, a very important thing. On the Mir station, actually, in one astronaut, we made a very strange finding. It looks boring here, but it's very interesting. What we did, for 2 weeks, we gave this astronaut a defined diet and measured what goes into the astronaut, what comes out of the astronaut. we made a balancing. And if you are healthy, then you should if you don't lose weight or win weight, you should, the same things which go in should come out again. So we especially measured water and salt. So what this astronaut did on Earth is, those bars here is in the salt balance. He just excreted the same salt which he ingested. He also excreted the same water which he ingested on Earth. Same experiment in space. He excreted the same amount of water which we gave him, but he stored salt, and he stored a huge amount of salt. He stored so much salt that if we would convert it into, usually we know when you store salt, then you also store water. It always goes in parallel. So he should have stored 6 liters of water. So when we weigh him, he should have been pumped up, but he was not. He did not store this water, but he stored salt. But this is forbidden. This is not allowed. So in every textbook, since 50 or more years, we know in physiology, salt and water go in parallel, period. If it doesn't go in parallel, you die. But this astronaut was very healthy, actually. So this was very strange for us. So now let's play chess. We said, okay, it may be an artifact. It's only one astronaut. If you make a small mistake every day, it is a huge mistake at the end, statistically highly significant, but still a mistake, and so on. So the question was, does this happen on Earth? And our usual guinea pigs on Earth are students. So we studied a lot of students with a lot of salt and found out really it is happening also on Earth. So we have a salt storage mechanism which just nobody had found before. And later we found out because the salt mechanism, storage mechanism starts earlier in space at lower salt concentration. So we found something because we had the opportunity to do it in space. So we have a salt storing mechanism. Now, if something works on students, we had a very clever colleague at Erlangen University, not at our institute. If something works in students in general, it should also work in rats. because because we are all from the same origin. So if a mechanism is important, it should also be available in animals. And rats have the big opportunity. You can look where the salt goes. So those experimenters fed those rats with salt and just then sacrificed the animals and looked to the different tissues, looked where is the salt. And I thought it would go into, I said it goes into bone. However, it did not go into bones, it went into the skin, subcutaneously. And so it was found out the skin is a salt storage, has a salt storage capacity, which is completely unknown. And this, there's a molecular mechanism. There are so-called proteoglycans, which can bind salt under the skin, and huge amounts, actually, of salt. Now, this mechanism contains salt storage in exchange for protons, and protons are in the acid balance of the human, and you can have a mechanism just to get rid of protons by your breathing and mechanism. And so we said, okay, if this mechanism is acting, then we should produce a lot of protons, and we should acidify inside the body. And if we acidify, we know acidification means bone degradation. The so-called osteoclasts are activated and degrade bone if you acidify. So we say, okay, would this mean that if you eat a lot of salt, you don't get only high blood pressure, but do your bones degrade? So we measured, and this I think is very important, we measured bone degradation, and we found if you eat a lot of salt, then your bones degrade more than if you lay in bed. So you have a real activation of bone degradation. So this links salt with osteoporosis. And very interesting, we always wonder why we cannot get rid, why we have so big problems in stopping bone degradation in astronauts. But now we know already at low salt, at normal salt ingestion, this mechanism is activated, and this activation makes us understand why we have big problems, or one reason why we have big problems in get rid of the osteoporosis. It's not the main reason, but it's one additional factor. You may remember Scott Smith saying that we should reduce the salt ingestion of astronauts. And astronauts, you probably all know, like to ingest salt because the taste is changing, so they use highly salted food. When we measure, usually they take about 2 or 3 times the salt they should use. So not only is this mechanism active, but there's an increased salt ingestion. Currently, we are doing experiments on ISS. It's so-called solo experiment, and we are very thankful to all the astronauts which participate in those experiments. But this clever colleague in Erlangen, he was also analyzing his skin in the microscope, and then he saw that in the skin of those rats, suddenly when they eat a lot of salt, there are so-called macrophages. Macrophages are little cells which eat up bacteria and viruses, and we know them as immune cells. But suddenly, those immune cells are in the skin when you ingest a lot of salt. So what he said, okay, there must be something linked, and let's just inhibit those macrophages when they are when you eat high salt and they migrate in. Let's inhibit them, because when they're active, they give out like some growth factors that make vessels grow in the skin and around. And so he applied some antibodies, and what happened? Very interesting, the rats developed high blood pressure. So there is suddenly a link between salt and the immune system and high blood pressure. And this guy now is getting very famous. So what I want to say, from this simple observation, we now have we now are able to get very new clues to the blood pressure regulation. And we have a completely new link that the immune system and the salt balance are linked. We don't know whether other immune cells are changing their function when you ingest a high salt. And we also have a link between salt ingestion and osteoporosis. Now, the 2 key people who found this, one in my institute, she was she was now taken up by industry. They pay her much more. She is getting very successful. And the person who, Dr. Titze now, he is being lured to the United States and got a very great offer, which he probably cannot resist. I think you will hear in maybe 10 years that blood pressure is linked to the immune system, and you may remember that you heard this here for the first time. Now let's go into the future. I use the same slide as you do. Now let's go into the future. What are our German perspectives for beyond ISS? I think at present we will use the ISS for research, like I just showed you. We also will use the ISS to prepare for future exploration. But what does the German government tell us? The German government says, okay, let's use the ISS until, as long as it's there, like until 2020, and then let's stop the involvement in human spaceflight. What the other European countries say are pretty much the same, very similar. So I could be frustrated, but I'm not frustrated. I actually find it a great challenge because it shows that we are in a pioneering field, and it's great for a scientist to be in a pioneering field. You never know whether and how it goes on. And also, if there is a vacuum, there's a chance to influence the future. If there's no vacuum, if everything is designed and decided, you just can go with the track, but if there is a vacuum, you can just influence the way it goes. So what we are doing now is saying, okay, how should we try to influence where we are going? And I think we can use the past to go into future and look what were the past reasons to make major investments in the future. Now traditionally first is religion always. You know, this was started, this is the Cathedral of Cologne where I work. It was started in 1248. And in the Middle Ages, those people wanted to get closer to the heavens and closer to God. And as they did not have rockets, they built something which looked a little bit similar. But it was an investment with no basic return. It was kind of a vision and visionary. But in the meantime, Cologne, as you may know or not know, is the richest archdiocese in the world, because the Catholic Church owns basically all which is around the cathedral, and that's the center of Cologne. So they are very, very rich. So this investment was not only good for religion, but it paid off and still pays off for Cologne. The other reason is leadership, peace, avoiding war, and I think this was the main driver for the human space program in the United States. And we always should remember that Kennedy said, I am not so interested in space. So he clearly said this was the reason, and not exploration was the reason. And the third reason, which I know, is economy. Columbus convinced by economic factors. So when we look at that, what should we do in Germany? How should we try to influence our leaders? And when we try to influence the way it goes, then we also can look back to some theories of how economic circuits are going. Now in the last Kondratiev cycle, which you probably all know about, was information technology. And I'm very convinced that the leadership of the United States in the last decades was really inspired by the human space program. And so what I think, how we can learn from this is in our thing to analyze what is the future bringing, and where could we inspire people. And I think, for myself, we need a symbol, we need a task. And for me, we in Germany, in Europe, we will not build your spacecrafts, especially if you privatize. But exploration on Mars, for example, needs a station and needs people to work in the station, to live in the station. So my question was, why couldn't we use this as an inspiration point and go on? And actually, it was, when I went to my DLR management, they said, yes, but we don't know what the future is bringing and so on. So I went to the local government and said, well, we need an inspiration, we need something for here. And so the local government gave me money to build a new facility. And this is DLR, some of you may know it. This is my institute here. This is the European Astronaut Center where the training is. And between there's a big field. And so I convinced the local government. They are inspired by exploration. They just say, this is great, this is fantastic. And they gave me a program. It's, well, for NASA people, it's small. We hear about billions, but this is about 45 million. And out of the 45 million in dollars, the local government gave me 30. So I went to DLR and said, here I have 30 million. DLR said, oh, if it's 30 million, we cannot say no. so now I convinced also our government, and we are just building, this is 3 weeks ago, building this facility. It's called Envy Hub. And we also need to get partners. And I think we have not to get the partners, we have for sure to get the traditional partners. And I just was in Houston and tried to convince the life sciences community for the United States also to team up with us, and I think we have great chances for this. But I have now lobbied with health insurance companies, and one company now is investing in us because we say, okay, challenges to care for an astronaut mean to have to do prevention. And health insurances want to go into prevention. So why not link those two things together? Private hospital. I have one private hospital chain, which is now investing also. For sure, we are collaborating a lot with the military. But when you have the vision of a Mars station, you can say, what do we need? We have to recycle. And recycling, I think, is one in the contractive cycles which are coming. One cycle is the life sciences, especially medicine and prevention, and the other is the so-called green industry, which will be a huge business. So why not team up directly with them, and also team up with people who try to fascinate young people, because we need engineers. Not all people should go into banking and investment and such things, but some people should also do inspiring work. Okay. So what we do here, we try to use the fascination of exploration to inspire and thus to stimulate economic growth. And therefore we will focus in Envy Hub on medicine and directly link up also with terrestrial applications, with the environment, and also with the outreach. Now this facility, if you look to it from outside, it is a huge roof, and all is under the roof, one floor. It looks like a moon, a Mars station in 100 years. This is the Regolith Street above it, and underneath are all the labs and all the functionalities. But this is not only a lab, but this is a facility with a lot of space for outreach and education, because we want to bring the public directly in where we work. We do not want to have museums. We want the people to see directly what we do. So this has mixed functions. We can also bring in the private human spaceflight people. We have here a lot for physiology. We have a small centrifuge here, virtual reality, so everything which you need for those purposes under one roof in order to a little bit excite people. And with this, I thank you for your attention.